Okay, now let's talk about chapter 2, graphs. Okay, graphs. Let's change the focus. What would have? Okay, good, excellent. So the first section, 2.1, the distance and the midpoint formulas. All right. Well, distance formula and midpoint. If we only have, for example, uh, a point, 2 points, A and B, and we construct the segments connecting A and B. And what is the distance between A and B? What is the length of the segment? Well, there's no formula. You just use a ruler to measure them. Okay? So the distance and the midpoint formulas are in the coordinate systems. So first, let's introduce the rectangular coordinates. Rectangular coordinates. All right. So in just if I just give you a blank paper and with 2 points, you can only get the distance by measuring them using the ruler. But if you have coordinate system, then we may have different way to solve it. Okay. So what is a coordinate system? It's like this. So we draw a vertical line and we draw a horizontal line. They are both number lines. They share the origin at the intersection point. They form the right angle. So that's why it's called rectangular. And they have units, right? And usually we consider the right side is a positive side of x, and the top is a positive side of y. Okay, and below it's a negative of y. Here is positive. It's -1, -2, -3, -4, -3, -4. Okay, so this is our coordinate system. And this horizontal axis, a horizontal line, we call it the x-axis. This vertical line, we call it the y-axis. And this intersection is called the origin. The origin, right? When we have the intersection of the origin, then let's check. For arbitrary point, for example, we have a point here. We have a point. Then this point, you project it to the x-axis. You project to x-axis. When we say project it to x-axis, we mean this has to be orthogonal, perpendicular. Okay, this is a projection. You cannot just get a slant line. That's not projection. Okay, when you project it to x-axis, you see the number 3. If you project it to y-axis, you see the number 2. Then we say the point P has x coordinate 3, comma, y coordinate 2. Okay, so this is a ordered pair. This is an ordered pair. This ordered pair first is always x-axis, x coordinate. This is x coordinate. And second is the y coordinate. Okay, so how do you get x coordinate? You just project the point to x-axis, see what it is. To project it to the y-axis, you will see the y coordinate. And because this plane, like let's consider this white piece of paper, and this plane, whenever you have a point, you can always project it to x-axis, and then you project to y-axis, you can get a ordered pair. So every point has a x, y coordinates. So every point has the unique x, y coordinates. Right? Every point has a unique x, y coordinate. And this origin has this special coordinate 0, 0. Because if you project it to x-axis, is itself, it's 0. If you project it to y-axis, it's also 0. All right? Okay, so for example, now if we have a point with coordinates let's see what it is, -3, 1. Then we can locate or plot it as following. What is the following? First, you check x. X is equal to -3. So you get this, you see, only over this line, the point on this line will have x coordinate -3, because if you project it to x-axis, it's -3. And then you get y equal to 1, horizontal. Y equal to 1, you project the y coordinate, you need the number 1, so this point should be on this horizontal line. And this vertical line, this horizontal line, they will intersect at a point. This point will have x coordinate -3 and a y coordinate 1. Right? So this is a way to locate or plot a point with a given coordinate. All right? So that's the way we can locate a point, and we can find the coordinates when we already have a point. Okay, so that's the rectangular coordinates, or xy coordinate, or sometimes they call it Cartesian coordinate. Let's see what's the word. Okay, rectangular, or Cartesian coordinate system. Cartesian coordinate system. Okay, this Cartesian, this one, because you get rectangle because this is a right angle, so that's a rectangle. Cartesian is because this system is designed by by a French mathematician with the name Descartes. Well, René Descartes is a French mathematician. He invented the system, so we use a Cartesian coordinate. Okay. All right. So in the Cartesian coordinate, in the rectangular coordinate, usually you just draw a cross, and with arrows x and y, and you can see that naturally you have 4 parts. Okay, you have 4 parts. This top right, top left, bottom right. Those 4 regions are called quadrants. So you see, this is the standard words. The coordinate axis, divide the xy plane into 4 sections, 4 regions called quadrants. You have 4 quadrants, then You can name them, give them order. This is quadrant 1. Quadrant 1. Here is a quadrant 2. It's so-called counterclockwise order. Quadrant 2. Quadrant 3. And quadrant 4. Okay, 1, 2, 3, 4 quadrants. And in each quadrant, let's check. If you have a point here, you project it to x-axis. You see, this point is on the right side of the origin, so it's a positive. If you project it to the y-axis, it's on the upper half space, so y is a positive. So here, x should be positive. If you have a point, then its x coordinate must be positive and y coordinate must be positive. Again, this quadrant only contains this section. The quadrant does not contain the axis. Two axes do not belong to any quadrant. Okay, so two axes do not belong to any quadrant. Okay, they are the border. Okay, so in the first quadrant, x must be positive. The point x coordinate should be positive. For the point y coordinate should be also positive. And if you get a point in the second quadrant, you see, if you project to x-axis, then this is on the left-hand side of 0, so it's negative. So x will be negative. But the y is still from the upper half space, so y is still positive. So second quadrant, x becomes negative, but y is still positive. In quadrant 3, let's check here. If you have x and y, it's on the left-hand side, so x is negative. It's below the x-axis, below the 0. You see, 0 is here. Below the 0, so y is negative. Right? And if you have a point xy from quadrant 4, you do projection. You project to x-axis. You see it on the right-hand side of 0, so x becomes a positive. But it's below the 0 here along the y-axis, so y is negative. All right, so this is the condition for the points with the coordinates x and y for different quadrants. What the property you need to know. Okay, so basically on the right-hand side, x is always positive because you project to the positive part of x. Right side, x positive. Left side, x negative. So right half plane, x positive. Left half plane, x negative. Left, this part, x is negative. Top half plane, y is positive. So this is top half plane. Top means above x-axis. Bottom half plane, y is negative. Below the x-axis, below the x-axis, the y should be negative. So that's the quantity property. Okay. All right. So that's the general introduction about the rectangular coordinates. I believe all of you are very familiar with this. So I just review it quickly. Now let's see the first part. Use the distance formula. Distance formula. Distance formula comes from the so-called Pythagorean theorem. It comes from the Pythagorean theorem. What is the Pythagorean theorem? if you have a right triangle, here's A. For the right angle, it has two legs. Those two legs are labeled by A and B. A and B give us the length of those two legs. And the opposite side with respect to the right angle is called the hypotenuse. Hypotenuse, H-I-P-O-T-N-U-S. Yes, hypotenuse. Okay, then the Pythagorean theorem says a square plus b square is equal to c square. This is a Pythagorean theorem. It's a very, very, very fundamental theorem in the trigonometry or in the geometry. Okay, so assume everyone know what this is. Now let's build the distance formula. What is a distance formula? Assume we have coordinate system. The distance formula works for all pairs of points. Remember, distance means the distance between a pair of a point. But in order to simplify the writing, we just assume we choose both points from the first quadrant. Okay, point 1, we have coordinate x1, y1. Point 2, we have coordinate x2, y2. Then what is the distance? This is distance. This one is distance. Distance is d. We are looking for d. What is d? Okay, now let's see what is x1. What does x1 mean? x1 means if you project it to the x-axis, this point is x1. x2 means if you project it to the x-axis, this point is x2. Okay? So that's our condition. Okay, then what is the distance between these 2 points on the number line? On the number line, we know what is the distance. The distance is the difference. So this horizontal segment has a length x2 minus x1. We use the right point to subtract left point. Okay? Okay, so next we consider the y1. y1 is a projection to the y-axis. This is y1. y2, you do the projection to the y-axis. This is y2. So this distance, the distance between these 2 points along the y-axis is y2 minus y1. All right, so far we don't have any right triangle. We don't have a right triangle. So what's next? Next, we are going to shift this parallel above. Okay, so we parallelly shift it upward. Then here's x2 minus x1. This side is x2 minus x1. Right? So this horizontal side is x2 minus x1. Why? Because you see, we have a rectangle. We have a rectangle here. Rectangle opposite sides have the same length. And similarly, we're going to move vertically this vertical segment parallelly to the left, to the right. So here. This segment has a length y2 minus y1 because you see here we also have a rectangle. Okay, so this is horizontal, this is vertical, so this the degree is 90 degrees. So we do have a right triangle. We do have a right triangle. For this right triangle, this is one leg, the second leg, d is a hypotenuse. So by the Pythagorean theorem, we know x2 minus x1 quantity square plus y2 minus y1 quantity square is equal to d square. Right? And we know distance. Distance is non-negative. Distance always greater than or equal to 0. If the distance of 2 points is 0, then those 2 points coincide. Okay? So distance of P1 and P2 is 0, then P1 is P2. Okay, it could be, distance could be 0 once you only have a point, not pair. Okay, because it's non-negative, we take square root, so we get our useful formula. X2 minus x1 squared plus y2 minus y1 squared. Okay, so this is our distance formula. This is our distance formula. Keep this in mind. It's a very, very, very important. All right. So inside this distance formula, you see we use x2 minus x1, y2 minus y1. But which point is x2, y? Which point is x1, y1? Which point is x2, y2? It doesn't matter. So it does not matter. Which point has labels x1, y1, and the other one is x2, y2. Okay, it's because x2 minus x1 squared. Remember, we have square. If we do not have square, it matters. But if we have square, it does not matter. If we do not have square, it matters. If we have square, it does not matter. You see, x2 minus x1 squared and x1 minus x2 squared, they are equal. You can check it. 2 minus 1 squared and 1 minus 2 squared. Once you square, whatever positive, negative, you always have positive. Okay, so you don't worry about which one comes first. You just do subtraction between x coordinate and the y coordinate. All right, so example. Assume we have 2 points. Find the distance. Between 2 points, 1, 3, and 5, 6. Okay, we're looking for the distance of this pair, 3.13 and 5, 6. Remember, this is an x, y, x, y. So the distance by the formula is x minus x, so 1 minus 5 squared plus y minus y. Don't mix them. And I don't care who subtract who, because you will always have the same answer. Okay, 1 minus 5, negative 4. Negative 4 squared is 16. 3 minus 6 is negative 3. Negative 3 squared is 9. So it's a square root of 25. 16 plus 9, 25. Square root of 25 is 5. So the distance between those 2 points is 5. See, it's very efficient. Okay, let's see another example. To practice them, we just change the pair of a point. So find the distance. D between negative 4, 5 and 3, 2. Okay, so distance is square root of, again, I don't care who subtract who, but it's always x minus x and y minus y. So you can never mix them. So negative 4 minus 3. Negative 4 minus 3 squared plus 5 minus 2 squared. You see, after you do subtraction, you have squared, then plus the square of the second subtraction. Okay, negative 4 minus 3 is negative 7. Negative 7 squared is 49. 5 minus 2 is 3. 3 squared is 9. So it's a square root of 58. Square root of 58 is itself. In the exam, this is the final answer. whenever I see it is approximated by something, it's wrong. You are not allow the calculator. So no simplification. No estimation, not simplification, estimation. We will see what simplification we can do, but no estimation. This is a final answer. Don't write a decimal approximation. All right. Okay. Let's see more examples. More fancy examples. So consider the 3 points. A is -2, 1. B is 2, 3. And C is 3, 1. Okay, we have 3-point A, B, C. Then we have several questions. First question, plot each point and form the triangle ABC. Okay, so we're going to plot it because all the y coordinates are positive, so it's always above x-axis, so we don't need the bottom part. The biggest number is 3, -2, so 1, 2, 3, -1, -2. Y coordinate 1, 3, 1. 1, 2, and 3. 1, 2, and 3. This is y coordinate. It's x coordinate. It's a 0. Okay, so where is A? A is -2, 1. If you have -2, 1, 1 you go up. So this is point A. -2 up, see 1. This is A. B is a 2, 3. 2, 3, B. C is a 3, 1. 3, 1, C. Okay, so this is ABC, and form the right triangle. Here, we plot 3 points, and then form the triangle. Form the triangle means we just connect those points. See? It's very possible we have a right triangle, but so far we don't know. We just have 3 points and then connect them. You have no idea if they what triangle they form. Okay, so that's point A. Problem A. Problem B, find the length of each side of the triangle. Okay, so we're going to compute AB, AC, and BC. So in geometry, I don't know how you label them, but usually this, you put AB and put the opposite value, it means the distance between A and B. Or you can write the distance between point A and B. The same thing, you can write either of them. Okay, so let's check what is the distance between A and B. A is here, so it's A, x minus x, so it's -2 minus 2 square, and plus y minus y, so 1 minus 3 square. -2 minus 2 is -4. -4 square is 16. 1 minus 3 is -2. Square is 4, so square root of 20. Okay, square root of 20 can be simplified as 2 times square root of 5, because 20 is 4 times 5. 4 is 2 squared, right? 4 is 2 squared. So you can move this to outside of square root. This is simplification, not estimation. Square root of 5 is not a perfect square. You can never leave a decimal approximation. You cannot, I say it again, you cannot get approximation. Okay, so the distance between B and C, B, x minus x, so So it's a 2 minus 3 squared, y minus y, 3 minus 1 squared. So 2 minus 3 is negative 1, squared is 1. 3 minus 1 is 2, 2 squared is 4. So it's a square root of 5. Square root of 5. Here is a square root of 5. AB is 2 times square root of 5. All right? And then let's check AC. The distance between A and C is the same as the distance between C and A. It doesn't matter who comes first, but normally we follow the alpha beta order, A, B, C, D. So I say the distance between A and C. You can say that the distance between C and A, the same thing. The same thing. They mean exactly the same thing. Okay. Okay, so A minus x minus x, so negative 3, negative 2 minus 3 squared plus y minus y, 1 minus 1 squared. Negative 2 minus 3, negative 5, square root 25. 1 minus 1, 0, square root 0. Square root of 25 is equal to 5. So this side is 5. Well, those numbers are the length of the side, not the coordinates. All right? Okay, so we finished the part B. Part B, we only need to find the length of 3 sides. Okay, part C. Verify that the triangle is a right triangle. Verify that the triangle is a right triangle. How do we verify a triangle is a right triangle? Again, the Pythagorean theorem. The Pythagorean theorem, beginning, we actually did not mention them completely. The Pythagorean theorem, the complete version is that if you have a triangle ABC, then this one is a right triangle. A right triangle. If and only if a squared plus b squared is equal to c squared. So basically, if we already know the length of 3 sides and they happen to satisfy this condition, then we can claim, well, this is a right triangle. That's a complete version of a Pythagorean theorem. Okay, so now we have 3 sides. Let's check. You have a 2 square root of 5 squared. 2 squared is 4. Square root of 5 squared is 5. It's 20. It's 4 times 5 is 20. And this part is square root of 5. And then squared is 5. The third side squared is 25. So you see here, this 25 is exactly the sum of 20 and 5. So we get square root 2 times square root of 5 squared. So first we verify 3 squared and see if they have some connection. We do find the connection, so we can set this way. This side squared plus this second side squared is equal to the third side squared. We check the condition of Pythagorean theorem, then we can apply it and get the conclusion. So by Pythagorean theorem, triangle ABC is a right triangle. Okay, so whenever you have that, you have a right triangle. For example, well, this problem is not done. Let's see this. If we have 3 squared plus 4 squared, what is this? It's 9 plus 16 is 25. Is equal to 5 squared. So we know that the triangle with side 3, 4, 5 is a right triangle. This is definitely a right triangle. Or you can get any others. For example, 1 squared plus square root of 3 squared is equal to 2 squared. This is a 1, this is a 3, equal to 4. So we know that if this side is a 1, this side is 2, this side is square root of 3, then this is a right triangle. All right? Yeah, so that's an example about this application of Pythagorean theorem. It's not part of a problem, so I just enclosed. Okay, we finished the part C. Let's see the part D. Find the area of the triangle. Area of the triangle. Right triangle. The triangle area is 1/2 base times height. Right triangle is better because you already have, you can consider one leg as a base, the other leg as a height. Hypotenuse is never useful in the formula of area in the right triangle, okay? So what is the area of the triangle? The area is equal to 1/2 base times height. What is the base? What is the height? Those two small numbers are base and the height. So you get 2 square root of 5 times square root of 5. 1/2 base times height. This large number, the number separated on one side of the equation, is hypotenuse. It's not the base, it's not the height. Okay? So 1/2 cancel with 2. You get square root of 5 times square root of 5. A square root of 5 squared is equal to 5. So the area is 5. Okay? So that's the answer D. And this is a complete example. It's a very fancy, but basically it just use the distance formula plus the Pythagorean theorem. Okay? Okay. Now let's see the second part, the second formula, midpoint formula. Midpoint formula. What is a midpoint formula? Let's check. Again, this formula works for all pairs of points from whatever quadrant, but in order to simplify the drawing, we only sketch them in the first quadrant. It's not just limited to the first quadrant. Okay. We have a point P1, which has coordinate x1, y1, and we have a point P2. It has coordinate x2, y2. Then you connect the P1 and P2, you get a segment. And then the segment has a midpoint. Halfway between P1 and P2. M is a point, so we want to know what is the relation between the xy coordinate of the midpoint and the x1, y1, x2, y2. What's the condition? What is the relation? Okay, first let's project it to the x-axis. We're going to study x and y separately, right? So here, this is x1, this is x, this is x2. Well, you have the midpoint, the halfway between them. If you get this right triangle, you see here, this part, this segment, they are equal. That's exactly the middle point, halfway, right? And these two triangles are identical, and sometimes they call it congruent. Congruent means they have the same length, same height, same angle, same length, but only different positions. Okay? Two triangles are congruent. For those two congruent triangles, then this side is equal to this side. Hold on a second, let me get some marker. this the horizontal distance, horizontal side should be the same, have the same length. Then the vertical side, okay, let's use this. The vertical side should also have the same length, right? Okay, so what is this horizontal side? This horizontal side corresponds to x1, x. So this horizontal side has length x minus x1. And here, this corresponds to x, x2. So it is x2 minus x. You always use the right number to subtract the left number. And they equal to each other. So you get x minus x1 is equal to x2 minus x. Okay, that's condition. Now that's also the relation between those three x coordinates. Now let's solve them. We move x to the left side and x1 to the right side. X and plus this x is 2x. And this x1 move to the right side. Here's minus, it becomes plus, plus x2. X2 is already in the left-hand side. You just add them. And then x is x1 plus x2 over 2. So this is a relation among the x coordinates of the two endpoints and the midpoint. By the almost same argument, you see, this is y1. This is y. This is y2. And the lower red segment corresponds to y minus y1. This red segment corresponds to y2 minus y. So you will have y2 minus y, this top segment, equal to the length of the bottom segment, y minus y1. Okay? It's the same process. Okay, and from here you are going to move this y to the right side and y1 move to the left side. So it's y1 plus y2 is equal to 2y. So y is y1 plus y2 over 2. So this is our midpoint formula. The midpoint M with coordinate x, y of the line segment from P1 x1 y1 to P2 x2 y2 is M. It is xy, and x is just x1 plus x2 over 2. Y is a y1 plus a y2 over 2. Okay. Okay, so here, this is addition. Addition means it doesn't matter who comes first or who comes second. So here we do have P1 and P2, but in the problem, you just have 2 points. It doesn't matter who is called P1, who is called P2. Okay, so you can just randomly have the P1, P2. You can call this is P1, this is P2, or the other way. This is P1, this is P2. It doesn't matter because you have the sum. All right, so now let's see the example. We will have this simple example. Find the midpoint of the line segment from P1, which is -5, -5, to P2, which is 3, 1, okay? And plot them. Okay, so if you do not plot them, we don't even care the coordinates, but later we are going to plot them. So let's draw this coordinate. We have negative 5, so it's above x-axis. 3, 1 is also above x-axis. Negative 1, negative 2, negative 3, negative 4, negative 5. This is negative 5. 1, 2, 3. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Negative 5, 5 is here. This is P1. P2, 3, 1, 3, 1 is here. This is P2. Okay, so what is M? M is 1/2 x plus x, so negative 5 plus 3, y plus y, 5 plus 1 over 2, which is negative 5 plus 3 is negative 2, over 2 is negative 1. 5 plus 1, 6, 6 over 2 is the 3. So it's negative 1 and 3, this is midpoint. And plot them, negative 1 and 3 is here. You can see that it really makes sense, right? If you connect them. Well, by my sketching, it's possible. It's reasonable. Right? It's reasonable. This is midpoint M. Okay, so this is our second formula in this section. The section is very short. We finished this section, and in this side of this section we have, it's a second formula, midpoint formula, and we have distance formula. Just keep them in mind and try some practices. I believe you can easily handle them. All right? Okay, so the lecture is not done. We will continue in the next video. Okay, thank you. We finish this video and we will start another video. Thanks.